All right. So we left off here in part one. So we are continuing here, reference angles. We're going to take a look at trigonometry of coterminal angles. We talked about it a little bit before, but we're going to look at coterminal angles in relation to reference angles. Okay, so take notes. All right, so trig of coterminal angles. If you recall, coterminal angles are like 0 and 360, right? 0 and 360, they are basically the same because if um, you start with one angle and then you go all the way around, the terminal side of those angles are the same. Okay, or like let's see, like 390 degrees. Yeah, 390 degrees is coterminal with 30 degrees. Okay. All right, so let's recall, or even negative 270 degrees is coterminal with positive 90 degrees. Okay, so let's recall coterminal angles. Coterminal angles differ by a multiple of 360. For example, 30 degrees and 390 degrees. They are coterminal. Okay. Also, trig functions of coterminal angles are equal, which would make sense because if they have their terminal side on the same place, then they have the same reference angle, right? So when we take the sine of 30, it's going to be the same as sine of 390 because 30 and 390, they both land at the same place in quadrant one, exactly the same place, not just randomly in quadrant one, exactly 30 degrees past the horizontal. Okay. All right. So if you're taking the sine of theta, it's going to be the same as sine of whatever theta is, plus or minus any number of 360 degrees. In other words, plus or minus any number of circles, because you're circling back to that same angle. Okay, so we'll just say theta plus some multiple of 360 degrees. So whether you add 360 or minus 360, or if you add 360 twice or three times or four times, you're still going to get the same location. And same thing with cosine. Ah, cosine is equal to cosine theta plus or minus 360 degrees times k. K is an integer, so k can be positive or negative. So that's why I don't write plus minus. It's already in the k. It's already understood. K is an integer here. K is an integer. You guys are like, what's an integer? Okay, so that's like 0, plus minus 1, plus minus 2, plus minus 3. Okay. let's use coterminal angles to find trig functions of angles larger than 360. So before, in part one, we looked at how to find trig functions of non-acute angles, but they were still between 0 and 360, right? We looked at like 135, we looked at 210, we looked at 300, but we didn't go beyond 360, right? So here in this section, in part two, we're going to be looking at these angles that are larger than 360 degrees. Okay? Or we could go in the negative direction, so we can go smaller than negative 360, so beyond negative 360. Okay? And the way we do that is by finding the coterminal angle and then the reference angle. But there are a couple of ways to do this, so let's take a look. Let's do this example. All right, so let's find the exact value. Whenever they say that, that's a giveaway. You're going to have a reference angle that's familiar, 30, 45, 60, or one of the quadrantal angles. Find the exact value of sine 405 degrees. Okay, so there, we've gone beyond 360. Okay, so how do we deal with these? Okay, so let's draw it so we can see what quadrant we land in. All right, so here is 0, 90, 180, 270, but we go beyond 360, so we're going to need to go all the way around again. 360, or at least until we have enough room for 405. Okay, so 360, and then up here we'll have 450. Okay, so we're good. 405 is somewhere between 360 and 450. So 405 is somewhere in this quadrant. Okay, so what happens is we go beyond 360 by that much. Okay, and that gives us 405 degrees. Okay, so those of you who are like, okay, I don't understand, why are we going beyond 360? When does that ever happen? Well, if you're a skater, then you know when that happens, right? When you're spinning and you're doing your 540s. Okay, so let's take a look here. This is the reference angle we want. This little bit right here. That's theta hat. Okay. All right. So again, a few ways to do this. Remember, when we find the reference angle is always an acute angle. Okay. So one way you can go about this is first find a coterminal angle that is between 0 and 360. Okay, because that's what we're familiar with, right? So you could do that. Okay, and you do that by subtracting 360 as many times as necessary until you get down to an angle that's between 0 and 360. Okay, so you could subtract 360 degrees as many times as many times necessary. Okay? All right, so we could do that now. 405 degrees minus 360 degrees, and that will give us 45 degrees. Okay? So we have our angle there. Okay? So theta hat is 45 degrees. Okay? So we have our reference angle. Okay? And we know the quadrant. So we're going to determine the sign, positive or negative, by the quadrant. Okay, so we're in quadrant 1. And so all trig functions are positive there. Okay? So we know that, what are we trying to find? Sine? Sine. Okay, so we know sine of 45 degrees is square root 2 over 2. And then, so now we can actually find the sine of 405 degrees. So it's in quadrant 1. Quadrant 1, sine is positive. So we will still take positive square root 2 over 2. Okay? Okay. Let's do another one just to make sure we understand this. Okay, so let's find the exact value. Find exact value. Find exact value of cosine 510 degrees. So again, we're beyond 360. Okay? All right, so another way you can figure out the reference angle is just by doing the drawing 0, 90, 180, 270, 360, and keep going all the way around until you find out which quadrant 510 is in. So 360, add 90, so we get 450. Add 90, we get 540. Okay, so I don't have to keep going anymore. I already know that 510 degrees is between 450 and 540. So 510 is in here. And so now this is 510 degrees, right? And so that's going to be my reference angle. So 510, how many more do I need to get to 540? 30, right? So that's another way you can find the reference angle. Okay, so it's going to be 540 minus 510, and that will give us 30. Okay, now cosine here is negative. Okay, so cosine 30 degrees is square root 3 over 2. Therefore, cosine of 510 degrees will not be square root 3 over 2, but negative square root 3 over 2. Okay? So remember, when you're taking trig functions, sine, cosine, tangent, and the other 3, of non-acute angles, you really have to be aware of which quadrant it lands in so that you can determine if it's negative or positive. Okay? All right. Okay, so we've been finding the exact values of these trig functions of these angles. Okay, so what if we have something that doesn't yield a reference angle that you are familiar with? Okay, so what if it has a reference angle that is not 30, 45, or 60? Or any of the quadrantal angles, 0, 90, 180, 270. Okay, so in that case, you will use your calculator and you can bet they probably won't say find the exact value. Okay. All right. So exact values not possible. Here, let's do this. Finding exact values not possible. Okay, so if that's not possible, then they won't ask you to find the exact value. So you will use a calculator. Use calculator and make sure you are in the correct mode. Make sure you are in degree mode. I think it's the next section. I can't remember. 3.2 or 3.3, we use a different mode. We introduce you to another mode. Okay, so make sure you're in the correct mode. In this case, degrees. Later on, it could be something else. Okay, and when you do this, you are going to produce a decimal answer instead of a radical answer, an answer with a square root. Okay. Okay, so for example, suppose you are asked to find the sine of 250 degrees. Okay, so here, if you try to find the reference angle of 250 degrees, so first of all, let's take a look here. 0, 90, 180, 270. Okay, so 250 is somewhere over here. And we see that here, we see that theta hat would be 250 minus 180, and that's going to give us 70. Okay, 70 isn't one of the ones you have memorized, right? You only memorize 30, 45, 60. Okay, so finding the exact value of this is not going to be possible, so you use your calculator. Okay, so if and you'll notice that here it doesn't say find the exact value. Okay, so if it doesn't say find the exact value, then that means you are allowed to use your calculator. Okay, in which case it probably means that your reference angle is not going to be 30, 45, or 60. Okay, so you don't have to even do any of this that I just did, but I wanted to show you why we would use our calculator here instead of doing all of this work. It's because when you do all of this work, you don't get a reference angle that you're familiar with. Okay, all right, so punching that into your calculator, you would do sine 250, make sure you're in degree mode, equals, and then you should get negative 0.9397. Okay, so just double check on your calculator, make sure you are getting this, because if you're not, then you're probably in the wrong mode. Okay, make sure you're in degree mode. Okay, and let's just do one more. Try this one. Find cosine of negative 160 degrees. So over here, it doesn't say find the exact value. Therefore, it's okay to use your calculator. Cosine negative 160, and you should get negative 0.9397. Okay. Okay. All right, let's stop there. And in the next section, we are going to, in part 3, we're going to take a look at solving for angles. Okay, We've done it before. We looked at how to solve for acute angles, but now that we've done all this work on non-acute angles, we're going to revisit the idea of finding or solving for angles, but this time they will not be acute. Okay? All right, I will see you soon.